Ever wondered how it feels to be like this?
Hello all, we are the ones behind this project we call a smart wheelchair. As we already did in the starting, just to make you slightly aware with the project outline of ours. So what basically this wheelchair will do is to possess a smart sense of operation as we control it wirelessly. So let's get started with exploring this prototype.
Now moving towards the block representation of a wheelchair. We have used an accelerometer as a sensing device. This accelerometer detects the data from the hand gesture of the wheelchair user. The data is fetched by the MSP430 launchpad, which is from Texas Instruments, which processes the data and produces the corresponding output. The output signal are sent to the air booster module CC110L. On the transmitting side, it is acting like a transmitter. The same air booster module CC110L is used on the receiving end for the receiving of the transmitted data. The data received is fed into another MSP430 launchpad. The IR sensors are used here for the purpose of providing safety to the wheelchair. The variations from the IR sensor are fetched by the MSP430 launchpad, which processes them and produces the corresponding output. The output acts as an input to the motor driver module, which processes the data accordingly and runs the motors.
So starting with the basic design of the wheelchair, we would like to emphasize on the fact that this wheelchair is made completely out of the scrap material. The water pipe and the joints in this prototype are all scrap material. Therefore, the net actual cost of this wheelchair is zero, although the actual model won't be.
Moving on, we have used two DC geared motors for moving the wheelchair and a caster wheel for extended free motion. This is the motor which we have used and we have placed it over here. Next up, we have used three infrared sensors for detecting obstacles in 3 directions and controlling the motion of the chair. Here are the 3 infrared sensors.
Move on to controlling of wheelchair. At transmission side, as the accelerometer ADXL335 senses the orientation of hand gesture, it produces an analog signal. It is a 3-axis rotation device, but here we are only using 2-axis for rotation of wheelchair. As the accelerometer tilts to downward direction, it generates a signal which is fetched by MSP430 launchpad. Now it gets decodes according to the coding. After that, it activates the ear booster pack for transmitting the signal. As these are high frequency signal, it has a good range to perform an action. Now we move on to receiving side. The ear booster at receiver side receives the high frequency signal and sends to another MSP430 launchpad, which decodes the signals according to the coding. And we are using here few IR sensor for safety purpose of the wheelchair. The action of the IR sensor is like an obstacle avoiding system here.
क्या था? किसका था?
These order
Now here we can see that even though the hand gestures toward the forward direction, the eye detects the obstacle and works against the movement and relatively performs the source code. And here is the still position. So as we come towards the end of our project, I would like to mention it again that it is not possible for a handicapped person to rotate the wheels of the wheelchair all day long. And thus here comes his liability to hire a person which performs his job for him. Through our project, we aim to give some sort of self-dependency to those who have been deprived of something such important. Now as a code of thanks, I would like to extend my thanks to all those who were directly or indirectly with us behind this project. And I would like to extend my special gratitude to the Texas Instruments India team for helping us showcasing our social idea on such a big platform at this global level. And last but not the least, a big thank you for you to viewing our video. Thanks.